Good afternoon, Brian. How are you doing this afternoon? We are really winding down to the end of the semester, which is a good thing, especially if you're graduating. Yay. All right, let's begin. This week we're going to be talking about geometric sequences. Last week we talked about arithmetic sequences. This week we're going to talk about geometric sequences. I believe geometric sequences are a little bit easier to write the equation for, but sometimes the problems get a little tough to solve. So a geometric sequence is any sequence where the numbers are going up by a ratio. For example, if I gave you something like 2, 4, 8, 16, 32. Now, an arithmetic sequence, they always go up by the same distance. So you're adding. This time we're multiplying. So here I'm multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So what you're multiplying by is called the ratio. So that would be r is equal to 2 in this problem. So in order to write an equation for a geometric sequence, it's the first term, so it's a sub 1 times r to the n minus 1 power. So it's a super simple formula, as long as you know what the first term is and you know what the r is. So this formula would just be 2 times 2 to the n minus 1. Boom, that's it. If I wanted to know what the, let's say the 7th term is, we just plug 7 in here and we end up with the 7th term. So writing a geometric sequence is fairly easy to do. So here's the formula. Okay. So let's say I gave you, let's say we had this sequence. Let's see here. Do it in red here. So let's say we had 3, 9, 27, 81, ... Okay. And I asked you to write an nth term for this thing. Okay. So all you do is you just say, okay, what is a sub 1? Well, that's 3. What is r? Well, 3 times 3 is 9. 9 times 3 is 27. 27. So my r value is 3. So my formula would be a sub n is equal to 3 times 3 to the n minus 1 power. That's it. That is how we write an equation. And this equation will find any given term. So if I asked you to find, like, let's say the 10th term out here, way out here, what's the 10th term? All we do is plug 10 in here, and that would just be 3 times 3 to the 10 minus 1, so 9th power. Oof, it's going to be a big number. Let me get my calculator out here. So I've got 3 raised to the 9th power. We always do powers first, times 3. So the 10th term would be 59,049. So that's it's pretty big. And when you think about it, they're always multiplying by 3 to get to the next term. So they're getting bigger and bigger really fast. Okay, that is a geometric sequence. We can also find the sum of a geometric sequence. So let's say I gave you, let's go back to that first one. Let's say I gave you 2, 4, 8, 16. This is a geometric sequence, and the next term would be 32. And I asked you, what is the sum of the S5? Well, S5 really means what is the sum of the first 5 terms? So 1, 2, 3, 4, 5. So if I added that all up, okay? So if I added that all up, I'm just going to clear it out and just do it in my calculator. 2 plus 4 plus 8 plus 16 plus 32, we would end up with 62. So S of 5, which means the sum of the first 5 terms, is 62. Now, if I said, what is S of 10? Do I really want to find the first 10 terms? So there's a formula. It's right here. It finds the sum of any number of terms. So S of n is equal to a sub 1 times 1 minus r to the n over 1 minus r. Okay, so again, this time I need 3 things. I need the first term, which I know, it's 2. I need the r value, which I also know is 2 because it's always multiplying by 2. And then I need the number of terms I'm going to add together. Well, that's 5 in this one because we know what the answer is. So we want to use the formula with something we already know. So in this problem, it would be 2 and then 1 minus 2 to the 5th over 1 minus 2. Okay, so if I work this out, I have 2 in front, and then on top, 2 to the 5th power, okay, 2 to the 5th power is just 32, so I have 1 minus 32, which is negative 31, over 1 minus 2, which is negative 1. Negative 31 over negative 1 is 31, so it really just turns out to be 1 times 31, which is 62, which we already knew the answer was going to be because we did it by hand, okay? So in this type of problem, it really is pretty easy to find the sum of a sequence. But let me tell you, geometric sequences get so big so fast that some of the values that you're going to get are huge. Because if you wanted to find the first 10 terms, remember the 10th term was 59,000 something already. So the sums do get pretty large. That's why this formula comes in pretty handy. Now, if it's a geometric sequence that is going to infinity, okay? So if they ask you to add up, so this is called a finite system because there's a specific number of values you want to add together. An infinite geometric sequence means that you want to add up an infinitely number of values, so it just doesn't end. Now, this formula only works if the R value is between 0 and 1. Well, it's the absolute value. So you could have negative 1/2 because that R value is equal to 1/2. So this equation finds the sum. So if I asked you to find, let's say I said, okay, I have 100, 50, 25, what is the next one? 12.5, dot, dot, dot. And I wanted you to find the sum of to infinity. You want to add up an infinite number of these values. Well, what's my R value? My R value is 1/2. It's always going down by 1/2, right? So my R value is 1/2. So I can use this formula. The first term, which is 100, 1 minus 1/2, so that's 100 over 1/2, which is 200. So if you added up an infinitely number of these terms, your sum would be 200. And doesn't that make sense? You have 100 plus 50, that's 150, plus 25, that's 175, plus another 12.5, so we're at 185.5, and then it just keeps getting smaller and smaller and smaller and smaller. It will eventually equal 200. It's kind of an interesting formula. So those are all of the formulas for today. There's 3 of them. So let's take a look at the practice problems. It says find the indicated nth term of the geometric sequence. They want the 4th term. Okay. Now this is probably the hardest problem on the practice, I think. But this is how I would do this problem if I thought about it. I'm looking at this, and it's like I want the 4th term. So I have 1, 2, 3, 4, 5, 6. So I want this term. I know this term. I know this term. I don't know this, 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 or this. I do know that they're all going to be over 4, right? The top doesn't change. It's only the bottom that changes. So let's say this was 4 over 1. Let's multiply by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 248. Oh. See, I just looked at, and it's a 9. It's like, okay, what am I going to get to multiply? So it's like, it must be 3s, and it does work. 4 to the 1st, 4 to the 3rd, 4 to the 9th, 4 to the 27th, 4 to the 80th. So it just asks, what is the 4th term? Didn't ask me to write an equation, so 4 over 27 should be the 4th term. Okay, that one was kind of, you got to kind of work backwards on that one. How about this one? It says find the nth term of the geometric sequence with the given a and common ratio. What is the 5th term? Okay, so this is really a1 here. So in order to write an equation, it's the first term times the ratio to the n minus 1 power. Now this is where a calculator comes in handy. It wants the fifth term, right? So I'm going to put 5 in here. So 5 minus 1 is 4. So this is going to be 5/3 times negative 1 to the third to the fourth power. Now I might do this without a calculator. This is 5/3 times. Now I know that if I take a negative number to a positive, an even exponent, it will be positive. So I just need to know what 3. So this is going to be 1 to the 3 to the fourth power, which is 81. So now if I multiply this across, I end up with 5 and then 81 times 3. Oops. 81 times 3. And that gives me 243. So this would be the fifth term. Okay, so what is that? 5/3. So this letter right here, letter D. All right, let's try the next one. The next one, it says determine whether the sequence 6, 18, 54, 162 is geometric. If it is geometric, find the common ratio. Okay, so Brian, is this geometric? And if so, what is the ratio? Okay, so now if I was going to do this problem, okay, first thing I do is I look at it and it's like, in order to find the ratio, it is a geometric sequence. In order to find the ratio, all you have to do is divide either two of them together. So like 162 divided by 54, or 54 divided by 8, oops, that's 54, divided by 18, or 6 divided by 8, oops, I did that wrong, 54 divided by 18, or 18 divided by 6. So you can divide two numbers next to each other, that will give you your ratio. And I believe the ratio is 3. So 3 times 6 is 18, 18 times 3 is 54, 54 times 3 is 162. So A is the correct answer. Very good. Excellent. That is correct. The next one, it says determine whether the sequence is geometric. If it is geometric, find the common ratio. Now, if it ever goes positive, negative, you know the ratio has to be negative. Okay? And why do we know that? Because in order, like if you had 2, and let's say your ratio is -3, so you'd multiply by -3. So 2 times -3 is -6. -6 times -3 is 18. 18 times -3 is -54. So if it ever goes back from positive to negative, you know the ratio has to be negative. Okay, so in this one, I'm going 27 to -9 to 3 to -1. That looks like my ratio is going to be -1/3. So yes, it is geometric, and the ratio is going to be -1/3 for that one. Does that make sense? If you're going from positive to negative, that the ratio has to be negative. And that is the only time the ratio would be negative, is when it goes back and forth from positive to negative, positive, negative. Determine whether the sequence is geometric. If so, find the common ratio. Okay? Brian, is this one a geometric sequence? Nope. It is arithmetic. It's just like last week. So all we have to do is say, no, not geometric for this one. It is arithmetic, just like last week, not geometric. So we don't have to do anything else. In this problem, it says, write the first 5 terms of a geometric sequence. Now, if they give me the first term, it's super nice. So they gave me the first term as -3. Awesome. That's my first term. Wants me to write the first 5. 1, 2, 3. So that 1, 2, 3, 4, 5. So -3 times -1/4. Okay, so that's going to be positive 3/4. Then I have to multiply by -1/4 again. So that's going to give me -3/6. 16ths. Then I have to multiply by negative 1/4 again. That's going to be positive 3, 16 times 4, what is that, 64? And then I'm going to multiply it again. It's going to give me negative 3 over 256. So I'm going to go with letter A. There's a lot of letter A's today in our answers. All right. Next question. It says, write the nth term of the geometric sequence as a function of n. Okay, well, what do we need in order to come up with an nth term? We need the first term. We have it. A sub 1 is equal to negative 3. Now, this is kind of weird. It says a sub k plus 1 equals negative 4 times a sub k. This is like a recursive formula, but this is what I need. In order to get to the next term, we multiply the previous term by negative 4. That means the ratio is negative 4. So now, it's kind of a little tricky way of trying to figure out what the first and the ratio is. But now I have the first term, the ratio, so my answer is going to be a sub n is going to equal negative 3 times negative 4 to the n minus 1 power. It's not letter A this time. It is. It should be letter D for my answer. All right. Brian, any questions up until this point? Last week we dealt with arithmetic sequences. This week, geometric sequences. All right. It says find the indicated nth term of the geometric sequence. It wants to know what the 7th term is. There's 2 ways I could do this. I'm looking at this and I'm thinking, okay, and I'll do it both ways. It looks like my R value is 4. It looks like 5 times 4 is 20. 20 times 4 is 80. 80 times 4 is what? 320. So that's my 4th term. Then I'm going to get my calculator out. 320 times 4 is 1,280. So I have 1, 2, 3, 4. This is my 5th term. So if I multiply by 4 again, I get 5,120. That's my 6th term. I multiply by 4 again. I end up with 20,480. That's my 7th term. So here's my answer. Now, I could have written out the equation. Remember the equation, a sub n is equal to a sub 1 r to the n minus 1. Well, my first term is 5. My r value is 4, n minus 1. So I want the 7th term. So if I plug 7 in here, this gives me 5 times 4 to the 6th power. Okay, 4 raised to the 6th power times 5. I'm just plugging it into my calculator, and lo and behold, I get 20,480 again. So 2 different ways of getting the same answer. Makes no difference which way you go. It doesn't make any difference. All right. This time it's asking us for S of 7. That means it wants to know what the sum of the first 7 terms are going to be. Okay, so the sum formula. It's a sum of 7. So that is, I got to remember it, a sub 1, 1 minus r to the n over 1 minus r. So that is the sum. So I know I need the first term. So a sub 1 is equal to 6. R is equal to negative 4. And n is equal to 7. So if I plug all my values in, I end up with 6. 1 minus, got to be very, very careful here, negative 4 to the 7th power, all over 1 minus negative 4. That's a 1, sorry, 1 minus negative 4. So the bottom is going to be 5. So this is going to be 6, and then there's going to be a 5 on the bottom. I don't know what this is. I have to put that in my calculator. So I've got 1 minus, and then I'm going to put that in parentheses, negative 4 raised to the, what was it, 7th power? And that gives me 16,385. Then I'm going to divide by 5. So I end up with 6 times 3,277. And that leaves me with 19,662. which is letter A. So this formula here finds the sum of a finite number of values, okay? Any questions, Brian, on that formula? All right, next problem. Evaluate the series S of 5. Now, I probably would not use the formula for this one. It's only asking me to add up 5 terms, and they already gave me 3 of them. So I'm just gonna do it this way: 1,000 plus 500 plus 250 plus, what is half of that? 125 plus, what is that going to be? 65.5? No, 62.5, I believe. Okay. So that's 1, 2, 3, 4, 5 terms. All right. So 1,000 plus 500 plus 250 plus 125 plus 62.5. And I come up with 19,000. Oh, there we go. I was going to say I don't see my answer. 1,937.5. So that's just another way you could do it. Now, if it was S of 10, I probably wouldn't do that. I'd probably just get the formula out and use the formula. But since it was only 5 terms, not so bad. And on the test, doesn't really matter which way. Oh, that was the last problem. Huh. That was the last problem on the practice for this week. Any questions, Brian, on any of that? All right, have a great week. It's supposed to be beautiful outside this week. It's supposed to hit almost 90 degrees on Thursday. Get outside and enjoy the weather. Have a good one. I'm going to be fishing tomorrow, that's for sure. I was going to sit outside, and I would probably go fishing today, but man, is it windy. Are you a fisherman, Brian? I'm telling you, it is the wind coming. The wind coming off the lake today is just crazy. Is it windy where you are? Yeah. Yeah, we're right on Negawicka Lake, and I mean the wind is coming right toward our shore. So it is super windy. I did get my boat out yesterday, so I am ready to go. As soon as the wind dies down, I will be out there fishing. Have you been out yet this year? No? Yeah, neither have I. I've not been out one time, and this is like the latest it's ever been that I've ever not been out fishing. What lake do you fish on? Multiple up north? Do you live up north, Brian? Okay, where do you live? You live down here in the southern part of the state? Near Toma. Okay, so you're Toma, that's over by La Crosse, in La Crosse area, isn't it? I'm thinking of the right. Okay, so you're way over there. Well, you got the Mississippi River. Lots of good fishing on there. I went to school in La Crosse, and my buddies and I, we used to go out fishing all the time. Yeah. All right, Brian, you have a great week. Get out and get some fishing in. Definitely.